Well, I saw this question on YouTube. I have my way of doing it. Three methods. I'm using three methods to do this integral. Now let's recall something. Here, this negative one. Negative one is equal to e to the pi I, right? Yeah, that's the negative one. Now, if you consider general solution, it could be equal to 2n plus 1 pi I, right? Because the every 2 pi is a 1 period, so every order number of a pi is equal to negative 1. So this one is negative 1 is equal to exponential 2n plus 1 pi I. Yeah. Therefore, log of negative 1 will be equal to 2n plus 1 pi I. And also, the integral of 8 to the power of x dx is equal to ax over log a, right? Plus c. Okay, good. Now, therefore, our integral, method 1, okay? Method 1, I'm using this, okay? The integral negative 1 to the power of x dx is equal to 0 to this one. It's negative 1. It's e to the 2n plus 1 pi I x dx. Now, these are just constant, right? This x is variable, therefore this one equal to integral d e to 2n plus 1 pi I x over 2n plus 1 pi I. Right? So this is constant taken out. So that would be 2n plus 1 pi I and e to 2n plus 1 pi I x. Okay, so this one is equal to, now this is negative 1, right? This is negative 1 to the, okay. So from 0 to 1, okay. This is a negative 1. So negative 1 to x, right? Over 2n pi plus 1 pi. So this one is equal to 2n plus 1 pi I. X equal to 1 is a negative 1. Minus x equal to 0 is a 1. Yeah, from another one. Okay, another one. Then we multiply by I, both top and the bottom. It becomes this. One becomes 2n plus 1 pi and 2I. Yeah, that's the result for the integral by method 1. Okay. Method 2. Method 2, I'm using this method. So this integral is equal to -1 to the x log of -1 plus c. Yeah? No plus c. I'm sorry. This is a definite integral. So, okay, that's it. And from 0 to 1, huh? Oh, we forget something. It's -1 to the x. This log of -1 is this. So it's 2n plus 1 pi I from 0 to 1. So this one is equal to, when x equal to 1 is -1. When x equal to 0 is -1. So this is 2n plus 1 pi I. And multiply by I, both top and bottom. You get a 2i and 2n plus 1 pi. Wow, we get the same result by method 2. Now method 3, I'm using substitution. Let t be -1 to the power of x. So x is equal to what? X equal to log t over log of -1. Huh? Yeah. Therefore, my integral becomes t. dt is this. D this, right? This is equal to dt over t times log -1. Yeah, that's right. Okay, let me check again. This is t. This is dt. This is dx. Sorry, dx is equal to dt over t times log of -1. Yeah. Now, when t equal to 0, this is when t equal to 0. Let me check. When x equal to 0, sorry. When x equal to 0, t is 1. When x equal to 1, it's -1. Oh, okay. I'm confused with this. So this one equal to t cancel out. If I switch it, that's become negative, right? From -1 to 1. And dt log -1. So this one equal to -1 over log of -1 and t, right? From 0 -1 to 1. And therefore this will equal to -1 log -1 -1 minus -1 here. When t equals to 1 is a positive one, right? So this is equal to -2 log -1. Then using, yeah, I, I, I did it in the beginning. Log -1 is this. So it's -2, 2n plus 1 pi I. Then I multiply I both top and the bottom becomes 2i, 2n plus 1 pi. Well, we get the same result by method 3. Thank you.